geht es um eine Cloud-Lösung. Unser nächster Referent ist Graham Martin, Geschäftsführer der EnOcean Alliance. EnOcean ist die Organisation der batterielosen Funktechnik. Der Titel seines Vortrages ist From Smart to Cognitive Buildings. Herr Martin, bitteschön.
Okay. Well, thank you and welcome. Today I'm going to talk a little bit about how the data from energy harvesting sensors can be put into the cloud to turn your building from smart into cognitive or self-learning. Now, what does this mean? Now, we've had smart buildings for more than 20 years. So we have buildings where we're collecting temperature data, occupancy data, lighting, etc. But the step that we're now taking today is that we're not just having this data or seeing this data, we're collecting this data and analyzing this data so that you can optimize your building. This could be optimizing the energy usage, it could be optimizing the space usage, it could be worker comfort. I'll show you a couple of examples here. First of all, we're all talking about collecting data. And the industry analysts are all telling us there's going to be billions and trillions of sensors to provide this data. The first important question we address here is, how are we going to power all of these sensors, and how are we going to connect all of these sensors? The solution that we use at EnOcean is called energy harvesting sensors, which means all of the sensors and all of the switches require no cable to power them and require no batteries. The products power themselves. And we use 4 different forms of energy for this. The first one is very simply mechanical energy. So pressing a switch, turning a handle, putting a card into a slot, walking across a floor. Anywhere where there's mechanical movement, you can harvest this energy, turn it into electrical energy, and use this to send wireless signals. The second way is simply room light. So we harvest the room light, we store this energy, and we power the sensors. By storing the energy, it means it also works when it's dark. Once the sensors are fully charged up, they will last for many days without any light. A third way is thermal energy. So a temperature difference of just a few degrees centigrade is enough to harvest energy to either send wireless signals or to turn on and off valves. The fourth is magnetic field energy. So if there's current flowing in a cable, there's a magnetic field. We harvest the energy here, and in this example, we can then send the data of how much current is flowing in the cable. So this is how we collect the data, and this is what makes it very easy. So you can go into a building and stick these sensors or switches anywhere, and then all of a sudden, you have data and you have controls. How this all works then, these self-powered data, they're all sending data according to the EnOcean standard. This is collected centrally in a gateway. It's then translated into IP and then goes into the cloud, for example, IBM Watson, Microsoft Azure, or in case of residential, it could be something like an Apple HomeKit solution. I'm going to show you some examples today of what we've done with the IBM Watson Cloud and how we're using this data to turn your building into cognitive or self-learning. So one project which is very popular is building utilization. So how much is an office or a factory or a hospital or whatever actually utilized? And it turns out that most offices in Western Europe are only about 60% occupied during the working day. And this means you're heating, lighting, cleaning, paying all these costs for 40% of space you're not using. This goes into millions and billions if you're a big company. So what we're doing here is we're helping companies to identify the usage by placing multiple sensors over everywhere in the building, and then over a period of a few months, feeding them the data of the occupancy. We're also adding the energy usage here, so the temperature of the building, the humidity, etc. So we also get a fit to see how much energy we're using and how much occupancy we have. And these are just some of the results. I'm sorry you won't be able to read this, but just to show you what's happening here. We found out a number of interesting things, but as I said, the occupancy is actually quite low. It's less than 60% during the working day. And this is down to desk level. So we had occupancy sensors on every desk and in every seat. So by finding this out, we also found, for example, we had 8 meeting rooms, and we really don't need 8 meeting rooms. They're occupied about 30% of the time. So by doing this, we're able to tell the people how to reduce the space requirements. So if you have like a building with 20 floors, you can probably close down 2 or 3 floors. You can close down meeting rooms. And this helps to save a lot of costs. What we also looked at is the energy usage. And this is just one example of a correction that we made which saved a lot of energy. The temperature of the building actually reached its maximum at 8 o'clock at night after everybody had gone home. So there's something wrong with the heating system here. The building is collecting the heat and retaining the heat. So in this case, all we did was we set the temperature back from earlier in the day, and all of a sudden you save 10 or 15% energy costs. Very simple. So this is one real example of utilization energy usage, just by going into an existing building, sticking the sensors, collecting the data, analyzing it in the cloud. There are other examples happening. For example, hotel rooms. Hotels and campuses are very huge wasters of energy. A hotel room is actually unoccupied about 2/3 of the time. If it's sold, it's only occupied about 10 hours a day, and about 1/3 of the time it's not sold. So if you're heating, lighting, you're wasting a lot of energy. So again, by just going in here and putting the sensors, you can make your building smart to save the energy, and you can make it cognitive by collecting this data and analyzing this data over a long period. Another interesting application area we're seeing is a very simple application like restrooms. And this is going more and more into a service model. So the traditional way is the restrooms are cleaned, for example, every 2 hours or every 3 hours, without actually knowing how often the restroom has been used. So if you're in an airport or an office or a motorway service station, you have no information how many people have used it. But really, you want to clean it after, for example, 50 people have used it. Or you want to go in and fill up the soap and the towels when it's almost empty. So again, by going into these restrooms and just sticking the sensors, you can check the occupancy, you can check the levels of soap, towels, bins. You can get this and you can send the staff in there to clean it and stock it when necessary and not just on a set schedule. And once you collect all this data over many months, you can help to optimize your whole organization. Another one is also in insurance projects. First one is preventing damage, and the second one is then analyzing damage. Obviously, preventing damage by having the sensors that give you early warning. For example, water leak detector, smoke detector, fire detector, that are then give you alarms or automatically switch off your water mains if you have a water leak. And the insurance companies, they're also able to get this data in the cloud and analyze it. Or a very big up-and-coming market is ambient assisted living. So we are all getting older, we're living longer, we're having less children. So we will need to look after people using these sensors. So you won't have to have a carer there all the time or as often. So by looking after the old people, you can create scenarios. You get over a set period of time, you get the data. When does Granny get up? When does Granny go to the kitchen? When does she go to the toilet? And over time, you know her routine. And then if something out with the routine happens, you get an alarm. So for example, if Granny gets up every morning at 6 o'clock, and one morning at 8 o'clock she's still in bed, there's something wrong. So then the carer gets the alarm and goes by. And what we can also do with these cloud solutions is we can collect also the data of the movement and the energy of the person. So we can see if the person's active, not active. We can also check the health status. So that was a very short overview of some of the things we can do with the data into the cloud in existing buildings or in new buildings, new applications. And if you're interested in more, we have the booth just in this hall, B60. The EnOcean standard, for your information, it is a worldwide standard for energy harvesting wireless, which means all of the sensors, all of the switches require no batteries, no cables. So thank you very much indeed for taking the time. If you have any questions, I'll be available here or at the booth. Thank you very much indeed.